Hi, grade 11s. Today we are going to look at the cosine function. We look at the transformation of this graph, which is a cosine graph. We'll transform it. In the previous lessons, we've been looking at sine functions. So in this case, we'll be looking at the cosine function. What we'll be looking at is the transformation, meaning how we transform this graph to give us new graphs. Let's look at how the examples are set. Here's one example. They say sketch the graph of cos x plus a half. Now, here I've got a graph of y is equal to cos x. I need to draw this one. If that's cos x, so what has happened to the graph of x? I added half. What does that mean? It means that all the important points are just at half to the y value. So which means that here the y is 1. I add half, so it means that the point would be minus the 360 is to 1.5. So the point would be up there. It means that the point shifts up. If I add a half to this point, to the y value, it becomes a minus 2/7 is a half because I add a half there, so the point is there. It seems as if all of these points will be shifting up by half unit, by half unit, by half unit, half unit, and half unit, and half unit, and half unit. Which means that if I were to draw this graph will eventually look something like this, and like this going there, and then also like that, going there, and there, and there to there, if I set by half. However, there's something extra they added. They said they only need from x starting from minus 180 to 180. So it means that I must start from minus 180 to 180. The only part that they need is only this part, which means that we've got to erase this because we don't need it. So you also don't need this. So the only part that is left is this one here. So eventually what they are requiring from you is a graph like this one. So your graph will eventually look something like that. Now, what kind of transformation is this? The question is the transformation. The graph has been moved half unit up. So transformation, we call it a vertical shift of half unit going up, then say up, done. What about the period? Now, because the original graph has y is cos x, this thing here is not affected, and the period of this graph is always 360. So if the x is not affected, x was not affected there, the x is not affected, therefore the period stays as 360 degrees. Let's look at the next example. Another example says, can you sketch the graph of y is equals to 2 cos x? So this graph here, it means that the y values are multiplied by 2. So the y is multiplied by 2, so that's multiplied by 2. It means I've got a point there, the y multiplied by 2 stays there. The y value here multiplied by 2 stays there. And this one multiplied 0 by 2 is there. Multiplied at 1 by 2 is there. Multiplied by 2 is there. And then multiply minus 1 by 2 is there. That stays there. Multiply the y value by 2 is there. You end up with a graph doing this, going down, and then going up all the way like that, and then coming down like this, and then going up like that. However, they said they want the graph from minus 360 to 0, meaning they only want this section, so they don't need this section here on this side here. So eventually your graph will look something like this one here. So we can answer the questions. So what transformation happened to the graph? If you look at the graph, it looks as it's been stretched like this. So we call that the vertical stretch by a factor of 2. What about the amplitude? Remember, to work out the amplitude, you take the highest y value in the graph, and you can say is 2. You subtract the bottom y value, which is minus 2, and then you divide by 2. And your answer will be 2 minus minus 2, which is 4, divided by 2, the answer is 2. Let's look at another example. They say here, sketch the graph of y equals cos 2x. In this case here, I'm affecting x. So what happens is that the graph now has got a frequency that is doubled, which means that each point will now move, or will divide this by 2, it will move to there, and then divide this by 2 to move up to there. All points will move by 2 units, but divided by 2. So which means that if I divide this 90, because I'm affecting x, divide 90, the point will be there. So I've got a new point there instead of this one, so the point will be here. So this one here will now, if I divide this by 2, it will be there. And this one, divide 270 by 2, that is 135. So this point here will be somewhere there. Divide this by 2, so it will be somewhere there. So if you look at this one here, so the graph now will come to something like this, and like that, coming up like that, to there. Because this is a continuous function, you can see the pattern of what the graph is doing. So the graph is doing something like this, and like that, and it's doing this, and all like that. So if I were to continue here, you can see the graph is doing this, to there, and then there, to up there, to turn there, and cut there, and then turn there, there, and stops there. However, they only want it from 0 to 360. They don't need this part here. So they don't need this part which is on the left here. It's only this part that they need, from 0 to 360. So which means that eventually your graph will look something like this. Now, what kind of transformation? Let's look at the graph here. It's as if I was squashing the graph. You see, I was squashing the graph. So we call this kind of transformation is the horizontal compression, right, by factor of 2. Okay, sometimes you can stretch it like that. When you stretch it like this, it means that maybe you can have half here. Okay, next one. What about the period? The period, you can see now I've changed here. There's a 2 here. So in this case here, so the period, you take the 360 degrees of the normal parent graph, and then you divide it by that value which is given there, which is 2. So the period of this graph is 360 divided by 2, which is 180 degrees, meaning how long is one wave? The one wave of a cos graph is like this. How long is it? From 0 to 180. It's 180. From 180 to 360, that's one wave. It's 180 degrees. Let's look at another example. They say here, sketch the graph of y equals cos x plus 45 degrees. So this one here, you can see that I'm affecting the cos x with the brackets. Remember that means like horizontal shift with all functions. So we solve for x here. So say x plus 45 degrees is equal to 0. So x is equal to minus 45 degrees. It means that the graph has been shifted 45 degrees to the left because I've got negative. So each point will be shifted 45 degrees to the left. So I'll shift this point, this point, this point, this point, all of them 45 degrees. So shift this, so it will be their point. Shift this, to be there. Shift this 45 degrees. This is 45 because that's 90. That's 45 degrees. 45 degrees. It's there. Shift this one 45 degrees. Shift this one there. So this one will be outside somewhere there. So which means that you can see that eventually my graph is something like this, and then to go like that, and then going there and there, going there, and then there and there. But if it was continuing, it will go there. However, they want us to only draw from minus 270 to 180. So from minus 270 to 180 to only here. So they don't need the part which is on the side here. So they don't need this part here. And also here, they don't need this part which is over here on the side. It's only this one here. So eventually, what you need, you can just erase that with a ruler, what you don't need. And then eventually your graph will look something like this one here. Okay, now answer the question. So transformation, what type of transformation? The graph, we saw that it was shift horizontally 45 degrees to the left. So the kind of transformation we'll say here is a horizontal shift of 45 degrees to the left. What about the period? You can see x is not affected there. I didn't multiply the x with any number. It changes if x is multiplied by a number. In this case, it's not multiplied by any number except 1, so the period is still 360 degrees like the original graph. Let's look at another question. It's this one here. This one, they say draw this one. What is this doing now? What am I doing? So this is now I'm changing the sign of x. I'm changing the sign of x. If I change the sign of x, all signs of x means that if the sign of x, look at the x here is 0, right? If I change the sign of x, it stays there, right? This here is minus 90 is to 0. This is 90 is to 0. This is 180 degrees is to minus 1. This is 270 degrees is to 0. This is 360 degrees is to 1. This is minus 180 degrees is to minus 1. This one is minus 270 degrees is to 0. This one is minus 360 degrees is to 1. So if I change the sign of x, so this becomes positive 360 to 1. It becomes that point. I change the sign of x, it becomes that point. I change the sign of x, becomes that point. Change the sign of x, it stay there. I change the sign of x, becomes that point over there on this side here. So what has happened? I'm just reflecting about the x-axis. It's just, there's nothing, it's one and the same thing. So the graph stays the same, it's the same here. So when I do this, the kind of transformation, let's say the transformation we'll call transformation, we can say it is just a reflection about the y-axis, because I'm using the y-axis, but there's nothing changing here. All right, so let's look at this one here. It's different from this one here because this one was y is equal to minus x. I was changing the sign of x. Now in this one, what are we doing? We are changing the sign of y. If I change the sign of y, so that point there becomes 1. So now it's 360 to minus 1. That point will be there. All right, so this one, you change the sign of y. Now this is minus 360, minus 270 is to 0. Change the sign of y, still remain as 0. So its point is there. Change the sign of y. So minus 180 is to positive 1. So the point is there. So this one will stay there because this is minus 90 is to 0. Change the sign of 0 is still 0. So change the sign of y. This point is 0 is to 1. Change the sign of y, becomes a minus 1. So the point is there. So this one is same as that one. Change the sign of y. That one becomes there. And this one stays there. Change the sign of y. So it's a point there. Seems as if the graph now looks like this. And that, like that. And like that. The graph does this. And like that. So this is, you can see that there's a reflection. That's a reflection. But however, they wanted us to draw the graph from 0 to 360, only the 0 to 360, so they don't need this part on this side. So you can erase it in the exam because you don't have a lot of paper. So you erase this one here, and then you are left with this part. So your graph will eventually look something like this. And then you can answer some of the questions. They say, what kind of transformation is this? It was a reflection about the x-axis. So it's a reflection about x-axis. And the period, I didn't change this, so it means that the period is still 360 degrees. Okay, ladies and gentlemen, can you try and do from your Siavula textbook, chapter 5, the functions, 5.6 cosine functions, exercise 5.24, 5.25, 5.26, and 5.27. Good luck, ladies and gentlemen.